Let me start recording before I forget to do that. And start the screen share for the Zoomers before I forget to do that. There we go. So yeah, it's one model. So if you are not using M+, make sure you use my starter syntax for importing the data, because there is a line in R and in Stata to remove the -999 values that M+ needs, but those packages don't. If you try to analyze your data with the -999s, it will think they're real numbers, and that will throw everything off. So word to the wise. Otherwise, M+ likes to yell about things if you're using that. So it can't be more than 90 characters across. That's a common problem I'm hearing about. I think R and Stata are not as tricky about that, but Stata you have to watch the comments, the 3 dashes versus the 2 and commas. Those are the ones that throw folks off. Vladimir, are you hearing questions from folks?
Not yet, but please read the instructions.
Yes, read the instructions.
What the expression paths are and what the covariances should look like. Because you can have different models just based on what you are constraining or what you are estimating.
Yep.
I would also recommend for those who like to leave R open like me, close it before you start.
Okay.
Just to get a completely refresh so that actually may compile when it should, even though it's not, and it goes right.
Fair enough. Yeah, R could be finicky, but I think that's true of a lot of packages. So shut it down and restart it is a good tech solution for most problems, as a first pass at least. So no questions on that? Then let me remind folks, I believe I sent this out over email, but we have office hours next week, office hour Palooza. Oh, no, not my calendar. I want this one, actually. Nope. There we go. That's what I meant to do. So I have my usual office hours on Mondays and Wednesday next week from 3 to 4:30. The minutes I would normally be teaching, I'm going to be in office hours, 12:30 to 3:30. So this is both classes, by the way. I don't think the other class is going to bother me much because they just finished their projects and they don't want to talk to me ever again. They're traumatized. Got cocky about the plus or minus 0.001. Yes, that's another thing. So I'd said you could do this in 3 different packages. I had to check to the level of 0.001 because so many of the numbers are comparable. And there are going to be a few spots where it's going to be wrong if you use one package that was right in M+. So try plus or minus 0.001 if you have a wrong answer and see if that solves the problem. There's a couple places where that may. If that's not it, then email us and let us know how we can help. All right, so yes, and then Vladimir, Tuesday? Yes. Tuesday's hours, yes, because everything is due Thursday night, so no office hours on Friday. You can sleep in. You've earned it. Yes, so ollie ollie oxen free, all right? I still don't know what that means, but that's what we used to say as children when we played hide and seek, and it meant everyone needed to stop hiding and come back together. So if you're behind and you've been hiding from me, come on back. Come on back, let's get everything done. Get it done, get it turned in. I'll turn in whatever grades you've earned by Thursday night. That's the plan. All right. Revisions to homework 4, also something you can be working on if you choose. Please use track changes and leave my comments in. I got a question earlier. Can you actually reduce your score by doing a revision? No. If you do a revision and it somehow makes it worse, I will pretend that never happened and just give you the first score, okay? I don't think that has ever happened. I'm trying to think of an example and I'm coming up short. Maybe if you decide to let ChatGPT write your revision, that could happen. I just spent most of the previous class having the students evaluate answers to questions that ChatGPT really did a bad job on. I wanted to show you this actually, since you will appreciate this having been in this. So 2 years ago, when ChatGPT was brand new, I came across this picture on Facebook. Actually, no, this one. Hang on. I have 2 pictures I wanted to show you. Opening them slowly. So this is ChatGPT's rendition of logistic regression. I see nothing wrong with this. This looks fine. So I just saw this and started laughing.
What's the Bavarian calcification?
I can share it. And so then I asked it today to try and do better as I was playing with this for the other class.
Has it improved?
2 years later, better,
No better.
spelled correctly up here. I don't know what decision boundary means because these look like cases that are more likely to be a 1. A boundary would be some sort of split. And then also, I'm pretty sure if you count to 10, there's not 2 8s.
And
And
if you're counting by 2s, you don't have a 9.
yeah, and the y-axis is labeled probably. Probability.
Probability.
Probability. So yes, we predict the log of the odds of the probability of a 1, but definitely not a 7, because we don't believe in 7s. This is straight up nonsense. So yeah, ChatGPT, maybe not so much. That's how you can do a worse job on your homework 4, is to let the computer try to do it for you.
Please share that with us.
I'd love to. Yeah, these things just crack me up. All right, so we're talking about mediation because we got to get your homework finished. So we're going to hit whatever slides we can do that matter and example 6A so you feel good about that, and we'll see if we have time for B or C. We'll see. How's that sound? All right. So I talked about this, but I realized I hadn't done the slides. So I do want to talk just a little bit about the logic of mediation so that you understand this, because there are certain fields in which it is a big deal. Mediation is a very popular thing to ask questions about. So I'm starting on lecture 6, slide 40. Someone was like, oh, she's doing mediation slides? I got to get there for that. So first things first, these are not synonyms. This is one of those tell me you don't know what you're doing without telling me you don't know what you're doing if you use them interchangeably. So mediation, to me, is regression with a better marketing campaign behind it. That is the way I think of it. Because the idea here is that if I have a variable x, for instance, that, like theoretically, what this is saying is that it causes the mediator, labeled m, which in turn causes y. So the fundamental question is, do x and y relate differently after controlling for m than before? Now that sounds to me a lot like unique effects in regression. Does x still predict y after controlling for m? That's a regression question. So the part of that mediation allows you to answer in addition would be, does x relate to m in the first place? Because that would be sort of implied by a regression model. Like predictor covariances are taken into account in figuring out what the slope should be, but it's not an explicit part of the story. But for better or worse, this lives on. Moderation is interaction terms. So that is typically depicted like this, but it's not really an estimable model. What this model in turn implies would be something like this. I have an x, I have an m, and then I have an interaction, and they predict y. So this is the idea that the relationship between x and y depends on where you are on m. Isn't because of m, depends on where you are on m. So I once had someone try to write a grant proposal in which one of the mediators they proposed was age. Can you guess my reaction? Can age be a mediator? Let's think about it this way. Something is going to cause me to get older, and the fact that I'm old is going to cause something else. I'm pretty sure the only thing that causes older is the calendar. Like time marches on. Age cannot be a mediator. It can be a moderator. How you relate from x to y could depend on how old you are. That's a reasonable thing. Age can be a moderator, not a mediator. So we've talked a lot about mediation across this, actually the whole year for those of you who've been here the whole time, and we're focusing on just this part right now. So again, the way this is phrased is, does x relate to y differently after controlling for some mediator or multiple mediators? And everyone on Earth has adopted this same terminology. Like you will see this pretty consistently. I know, for once. So the path from x to m is labeled A, the path from m to b is labeled B, and the one from x to y is either C or C prime, as they call it. Different kind of C is what this means. And the question is C different than C prime? If so, then we have evidence for mediation that after controlling for m, the relationship between x and y is different. Some genius figured out that the test of whether C differs from C prime is the same thing as asking whether the slope A multiplied by the slope B is significant. The result of that product of these two slopes is called an indirect effect, whereas each individual slope is called a direct effect. So indirect is a multiplication of two or more slopes. That's what it is. Now, this doesn't hold all the time. There's exceptions for latent variable stuff and maybe generalized stuff, but this is sort of the basic thing that you can do in most cases. So there is a seminal paper that was published in 1986. It's been cited like 8 bazillion times. And back in 1986, this is how you did it. You started with a model in which you have X predict M, and then you have a separate model in which you have M predict Y, and then you have another model in which X predicts Y, and then you stitch the results all back together. Well, that works okay, except it's fairly limited in practice when you want to do more complex things, like have multiple mediators and multiple kinds of indirect effects and potentially have interaction terms as part of the story. So the old rules that can now be broken after more folks have done research based on this as a starting point, X must predict Y in the first place? No, it doesn't. That does not have to be true. The question is the relationship between X and Y different after controlling for the mediator? Different could mean was significant, isn't anymore. Wasn't significant, now is. Was positive, now is negative. Was negative, is now positive. Different takes a lot of forms. That's all it has to be.
Could
Yeah.
different mean different levels of significance?
Different levels of significance. So if something was significant, became non-significant, that is full mediation as a label. And if it became less significant, and don't ask me how to operationalize that, it's partial mediation. If you had a significant relation between X and Y, and it was reduced in size but still significant, people would call that partial mediation. If it were reduced in size and to the point where it was non-significant, people would call that full mediation. Those are older terms. Different is different. However, old rules that probably still do hold, or pry in my Midwestern vernacular, X must predict M and M must predict Y. Otherwise, there's no point. Yes?
Lisa, have you found a reference that we can use in those cases that we have different type of outcomes? For instance, we have a normally distributed predictor or a continuous predictor, but a categorical outcome.
I remember looking at this with you like last year maybe or the year before. I have a few resources I can probably send for anyone who's in this position. But essentially what's going to happen, like if Y is binary, then the scale of this indirect effect gets really difficult to interpret, but I think it's still valid to do. Because let's say that X is a quantitative predictor, M we'll say is conditionally normal, and Y is binary. Well, then X to M is in just regular, like no link function metric, but M to Y is in logits. So then you have a regular times a logit, and I don't know what to do with that, like in my head, but I think it's still valid to ask if the indirect effect is significant that way.
Do you standardize those and multiply? I'm just,
Yeah, the closest thing that you could do is switch to probit, because in probit, the model implied variance of the pretend underlying variable we don't have is 1. And so like if you z-scored everything else, then there have variances of 1, and it's kind of closer to something. So you may see probit used for that reason in this context. The hardest situation is when M is categorical or nominal, because then like the X to M part needs a link function, but then this is treated as like a series of dummy codes on the other side, because it's a predictor, not an outcome. So then it depends on what your software is doing, what actually happens in terms of estimation. So it gets complicated fairly quickly when you introduce generalize.
SEM question that you could possibly look at in the fall?
I won't get there, but the method of estimation that we'll talk about, or I won't, Jonathan will, in the fall, is known as limited information estimation, is used to sort of circumvent this problem. It's sort of to turn this into something that's more like a continuous variable in terms of that. Yeah. So yes, this is mediation here. There's a bunch of different ways to compute the standard error of this product of A and B. Like, people fight about this, there's whole lines of research about it. I've tried to care and I just can't. I just can't. There's no room in my head to care about this. I got to care about so many other things. So I don't care about this. So I will tell you, I put a bunch of stuff in here about it. Bootstrapping is one of the more acceptable things. There's various kinds of bootstrapping that people use for this. The reason that I've decided that I can't care is because whenever I've actually gone to the trouble to do things the right way, the p-value was different in the third decimal spot. And it didn't matter. So there is a whole literature about this. Here's some resources here about what is currently best. I got a little bit of resources here in terms of mediation with non-normal variables. So in M+, for instance, they have some descriptions of this. And then this is what I just said in terms of changing scales across that. So mediation with stuff in the middle that needs a generalized model is especially tricky. Stuff at the end is a little bit less tricky as well. There. Okay, slide 48. How's that? Stuff that I skipped. Let me see if there's anything in here that I want to spend time on or that isn't less for your future reference. Yeah, so complications, these slides are fairly self-explanatory. I did have a mention of this is limited information estimation. You will hear about this in the SEM class, but you already know about this part of it. This is tetrachoric.
That's from the beginning of the term.
Yeah, this is from the beginning. So it turns out that if you want to do factor analysis on a series of binary or ordinal indicators, what happens is that you first build yourself a tetrachoric or polychoric correlation matrix, and then the factor analysis uses that to figure out what the parameters are that make the relations between your variables as close to what the model says they should be. So this gets used in, these ideas will show up in multivariate models and in structural equation models as well. There comes lots of things, yes. Let's see. Yeah, the rest of this I think is fairly, I don't need to read you my own slides kind of thing, but we'll see this trick right here. One of the difficulties in terms of putting in dependency in path models. So in your homework 5, one of the instructions says that this variable and this variable should have a residual covariance. This one and this one should not. Right? So you're allowed to just put in relationships to make sure that the outcomes from the same person, their relationships are adequately reproduced by the model. That is only possible, though, if you have residual variance as an estimated parameter. Throughout this semester in generalized, when did we have estimated residual variance? For binary, did we? Ordinal? Nominal? Binomial? Beta? Beta binomial? Gamma? No. Only in normal or log normal.
We assumed that we had full data, whatever we were working with, right? Is that why we didn't have to do that?
No, it's a question of, is residual variance a parameter in that distribution that you're using?
Oh, okay.
And it only is in normal. Like in everything else, it's not. So the idea of introducing a residual covariance, meaning a correlation between the residuals, can't happen if you don't actually have residuals and residual variance as part of your model. So there's another way to do it, and that is to sneak in a correlation between, say, two binary outcomes or ordinal outcomes through a latent factor. So if I get a chance to show you, that's an example 6b. But here is M+ code, for instance, to be able to do that. You essentially create a new variable and then have it predict these two things, and that induces a correlation between the two things through that new variable. You'll get to hear more about that in SEM as well. Okay, I think that's all I wanted to say. This is for Stata folks. Stata, to me, has way more options for generalized models in path analysis and structural equation models than M+ does, and certainly more than the R packages I'm familiar with. Here are all the choices. So a large menu of options and combinations of links and distributions for that. All right, where is example 6a? That's what I want to do that. While I open that, questions or comments?
So M+ doesn't have a lot of options for generalized things.
It has more than R, Lavon at least, but it has binary, ordinal, nominal, and count family. It doesn't have anything in the binomial family or gamma. Yeah, I don't know if they're going to put that in there. They've put all their recent developments into Bayesian whatever.
Oh, okay.
So I have not seen any discussion on their webpage about adding to the generalized models.
And, R can only do binary and ordinal?
So the Lavon package in R, which is what most people use for SEM, only can do binary and ordinal, and only in limited information estimation as well. No true maximum likelihood for that. Vladimir, are you aware of any other R packages that have link functions in path models or SEM? No?
I'm not used to that analysis in R.
No, but you can use Stan or JAGS, right?
I think so.
Base it up.
That's what Jonathan would say.
Yeah, that's what he would say, and I would say, no, I can't. No, thank you. I do not like that. All right, this is the example we were looking at. So a couple things that I've had in conversations with folks who are working on homework. Your homework path model will look very little like this because you have 4 outcomes on like this side. I think you have 3 or 4 mediators and like 1 predictor in front. So for instance, in my code, I'm able to compute the total of the indirect effects and the direct effects for this y. Like you would have 4 versions of that if you were to do the same thing because you have 4 boxes at the end of your mediation chain. However, I do not believe I asked you to do that. So you don't have to do everything that's in this example in terms of the code. You only need to do the ones that are requested. So the story here, we have flavors of sexism as mediators, mindfulness as the X, and then a measure of warmth towards feminists as the Y. And what we looked at last time was code to fit just that path model. Do we want to go back over any of this? Folks who are using the code on this, would you like a refresher on anything? And if so, which package? I've got 3. Hey, the people who show up today get to dictate the program. I want to make sure y'all can do your homework and then eventually use these models. Yes for R? Okay. Yes for R. So the reason that everything is green, just to orient you, this is a quote right here, quotation mark. There is a terminating one down here. So everything in between here is an R object that's just a bunch of words. That's a weird aspect of it. You then feed this object that tells R what your model should look like into a call to Lavon, latent variable modeling. So it goes in the model argument here. So remember, hashtags are comments. So above each section of code, I'm telling you what it's doing. So 1 squiggle is a slope. The *1 means it's a slope to be predicted for the intercept. In other words, these are the fixed intercepts. It's a roundabout sort of way of doing it. These, in parentheses, are labels. We don't need them yet, but they are here because the next model is going to be a multiple group model in which we would want to constrain these to be equal or not across groups. And the labels are the way to do that. We also have, here is the X to Y path. So 1 squiggle for that one. Let me see how far I can zoom in. By the way, this is a tilde that's above the tab key on the left-hand side of my keyboard. So I labeled left side of the model, and then the 4 mediators, because I can't keep these variables straight in my head since I'm not a social psychologist who understands them. They're just M1, 2, 3, and 4. And in the paper, that's what I did too. I labeled them that way.
You labeled them
I
very
did.
well in your diagram.
Because I was like, there's no way I'm going to keep these straight. These words don't mean anything to me, so they're just 1 to 4. And then the right side of the model, warmth is the Y outcome. And so it is being predicted by 4 things in this statement right here, separated by plus signs. So it's not literal addition. It's the idea that I have 4 predictors of 1 outcome. 2 squiggles is how you set up a covariance, an undirected 2-headed arrow relationship. And if it is a different variable on either side of the 2 squiggles, that's a covariance. If it is the same variable on either side, that is a variance. So a variable covarying with itself means it's variance. So those are listed, for instance, right here. The variance of each variable is intern with intern. So that's the variance of the first mediator, of the second, and so forth. Okay, how are we doing so far? Okay, now indirect effects. I know that there are easier ways to get indirect effects in standard software for these kinds of standard multivariate normal path models. But I wanted to show you a more general routine that will work with more kinds of models.
Also very understandable, you see exactly what you're doing.
Exactly, yeah. So the logic here is this is analogous directly to GLHT in R or LinCom in Stata. We are building linear combinations, except in this case, it's actually a nonlinear combination because they're multiplying rather than adding. So the name that's on the left-hand side of this colon equals deal here, this is a new parameter that is being created. So in LinCom, it doesn't make you name things. In GLHT, you can put in quotes what you're creating. Like this is analogous to that. This is a label. So I named it X to M1 to Y because I'm creating the indirect effect that goes from X up to the first mediator and then down to Y. And that is built from the labels that I put on the paths. So these have to be internally consistent or it will be mad at you. So X to M1 is saying, hey, that's this slope. Whatever that relationship is going to be, save that number and stick it right here. And the same thing happens for the M1 to Y on the other side. So that is the A times B. I saved it as this name. So I have 4 of those because I have 4 mediators and 1 outcome. And then because some folks like to do it, I created the total effect, which is the 4 indirect effects, plus the direct effect of X to Y. You don't need to do this in your homework. I just wanted to show you how you would do it. And total indirect effects would be minus that last thing. So this is like all the ways that you can get from X to Y through the M's. That's what it would be. Okay, then to estimate it, tell it what the name of your data is, what the name of the syntax object is, what kind of estimation you want. The R on the end, by the way, stands for robust. This is your protection against deviations from multivariate non-normality. And then the bottom is asking what kind of output I want from my summary. I'd like fit, R-square, and standardized solution for this thing. Okay. Questions or comments on that much?
Just one.
Yeah.
So will if there's only an initial predictor like this model, or like the model that we're using on our homework, will that always be a 0 for the proportion of impact that it has?
Any variable that is unpredicted should have an R-square of 0.
Whether it starts like here and here, both of those aren't predicted, those should always be 0 then.
Yes. Path models, at least for English speakers, are drawn from left to right or top to bottom, most commonly. So it would be weird to me to see something unpredicted on the right-hand side, but just because that's the bias in how I'm used to processing information. So anyone know what path models look like for speakers of right to left languages? Anyone? Anyone seen like that? Any language experts in the house? A few of you are.
Yes, it's probably the same, only because that it's like standard across industry, how they set up their flow charts.
Yeah. I imagine if the content is taught in English, then it would be like the English version of the path model, but if the content is taught in a different language, then it might change. But yeah, it's top to right or left to bottom. Nope, not top to bottom or left to right. There we go. And I'm doing it backwards in front of you because I can't reverse my own self. Okay. So R, what estimator did I say to use in your homework? Was it MLR or ML? Vladimir, do you remember?
MLR.
Yes.
MLR?
That was in the lab.
Okay, so that means folks who are using Lavon, look at the second column labeled robust. That's where your stuff is. So in this model, we have a test statistic of 0 with 0 degrees of freedom. Why?
Justified.
Just identified, yes. We put in every possible pairwise relationship that we could. Therefore, do we need to worry about misfit? No, we're good. It has to fit. We have perfectly recreated the relationships that exist in these data. Now we got to figure out what they are. So fit is irrelevant to the story here. So these tables are organized similarly with some extra columns. So the slope or intercept or whatever it is, the estimate of the parameter, standard error. This is your hypothesis test. There's your two-sided p-value. This column you can ignore. This is standardized with respect to latent variables, which we don't even have any. and then standardize with respect to everything. What that does is turn every variable in your model into a z-score. Mean 0, variance 1. Question? Correction?
Yes, to me, in homework is ML.
It's in OSML.
Yes, sorry.
Okay, so then either take out the R here, or just stare at this column. Yeah, so I think so these standard errors will differ if you have the R on there or not, but the estimates will be the same. And I do not believe I asked for standard errors, because I knew they wouldn't match. The estimates will match. So we would interpret this one, for instance, just like any standard regression slope. Let's find one that's significant. That's more interesting. So internal motivation about sexism something is predicted by mindfulness. For every additional unit of mindfulness, that M1 mediator increases by 0.33. That's it. I mean, you already know how to do this. It's just all of them at the same time. Everything, everywhere, all at once. Is that a movie a couple of years ago? Path analysis. Everything, everywhere, all at once. So yeah, you just got to figure out the outcome is the first word. The predictors are the second words, and that's true in M+ as well, in terms of how they organize the output. Then we get down into covariances. So we have the 6 covariances among the 4 mediators that I had requested. And the dots, by the way, that indicates that these are residual covariances, meaning it's the leftover parts of these variables after being predicted that get to covary with each other. Yes?
Sorry, this about last class, you said that people don't center predictors in path analysis. Right? Do you think that's needed?
I think that they should be, ideally, yes, because where that will show up is your fixed intercepts will be off, like they'll be weird if you don't center the predictors that go into them. But if you don't have interaction terms, that will be the only consequence. Yeah, I don't think these things are centered, or else they're all on a scale where 0 is part of it. I don't remember, to be honest. I'd have to reread the paper.
Okay. Another question is, can we have interactions and moderations as part of the model?
Yeah, you can. The easier way to do it is as a multiple group model, which is what the next one is. But yeah, you can put interaction terms in these things. It would be, what you have to do is physically make the interaction term as a variable in your data set, and then that's a new box in your model. Unless it's an interaction with a latent variable, in which case you need to come back to the SEM class, because I'm not talking about that today. Same thing with the column labeled intercepts. The ones with a dot are actually intercepts. The ones without a dot are means because they're unpredicted. So it's just the mean of the variable if there are no predictors to be conditional on. And same thing with variances. And then R square, variance accounted for. These are our effect sizes. So we did a good job predicting warmth. We did a crap job predicting all the mediators. Question?
So up there, it's labeled Y variable. Now, is that because there's only one endpoint?
You mean this?
Yes.
It's var
Well,
stands
Y
for variance.
But still.
Yes.
So if you had multiple endpoints, would you have like Y1 variance, Y2 variance?
Yep. Yep, in the same way that I have 4 mediator variances, I would have like 4 Y variances, or however many, assuming you're treating them as multivariate normal, in which you have one. Otherwise, you don't have one. Yep. And then defined parameters. What are these? What would I call them in English or in a result section? X to M1 to Y, for example.
That's your C prime.
Here's a clue. It's what?
Indirect effect.
That's it. Indirect effect for the win.
Keep throwing out some terms.
What are indirect effects, Alex? So yeah, these are the multiplicative combinations of the path from X to M and then M to Y that we made. Because there's 4 M's and 1 Y, I got 4 of these. If I had 4 Y's, how many could I have? If I had 4 M's and 4 Y's with my 1 X, how many indirect effects are possible? 16. What if I added 4 X's? Exactly.
Pain in the
Oh
butt.
dear. Yeah, this gets big real quick. So not all of these may be of interest theoretically. Not all of these would be eligible to be meaningful indirect effects because if you don't have the first part of the x to m, then it doesn't really make sense to keep going. But it can get real big real quick, is the punchline to that.
Exponential growth.
Yeah, exactly. Does anyone want to go over the M plus code? Anyone working in M plus? I know Rebecca is. Not very.
Yeah, but we don't have to take class time.
Okay.
Because I know
Class time is always precious, but so is your time outside of class working on things. So if there's things I can help with, we're happy to do so. Same information, organized differently. So M plus users, you have to scroll a lot. Never ever hit print for an M plus output file or you will kill all the remaining trees on this earth. Yeah, don't ever try to print an M plus output file. Like, it's voluminous. It goes on for pages and pages with a bunch of extra crap that you can't shut off. So you got to get good at scrolling or hitting Control F to find where your results start.
Print to a PDF.
That could work, but I mean, like, no paper.
Actually, no,
Yeah, to save your M plus results, the .out out files, they're text files. You can open them outside of M plus. So you don't have to log back in to look at your output. Open it in Notepad or TextPad or any text editor.
Cool.
Yeah. So these model results, by the way, that are right after all your fit stuff, these are unstandardized. So we get the estimate, standard error, the z-test, and the corresponding p-value. If you want standardized, you got to keep scrolling. And I don't have it in here, but there's a whole nother set that's the standardized version.
Does it have like a label saying this is the standardized?
The label says STDYX for standardized with respect to Y and X. There's other kinds, of course.
And I'm sorry, briefly going
yeah.
back up, so the columns that you were showing us before, those were unstandardized.
These are, yeah, model results are all unstandardized. So I actually like the way Lavon does it better by tacking on 2 more columns to make it easy. But M plus also gives you standard errors for the standardized effects, whereas Lavon does not do that. So it's a nice thing. Do I have model indirect? Yeah, I do. Okay. So let me just talk about this very briefly because I've had questions about this. To make indirect effects in M plus. So we're doing the same principle as in Lavon. I have labeled all of my slopes ahead of time so that it knows, hey, can you tell me what the number is going to be for this, and take that number and go stick it down here and use it in math? So model constraint is a subcommand that inputs constraints if you want them, but it also creates new linear and nonlinear combinations. So the new command here first, you have to name each of the quantities you're trying to compute. So I have as many names here as I have left-hand things on the equal signs, and they have to be the same names here, here, and tied to the same names up here. Everything has to be internally consistent. This method of building indirect effects manually will work in any kind of model. It takes a lot more work to do it that way, and they built a subcommand, model indirect, that will work in this case. For anything for multivariate normal, it will work. So it will give you all of the indirect effects getting from X to Y. So if there were 64, for instance, like you could request 4 things and it would work it out. So it's a lot quicker in that way. The only problem then is that you have to dig through the output. So a whole bunch of stuff to go and search for. All right. Any Stata users want to talk about their code? Are we feeling good about that? I can scroll up for a minute. No, we're good? Do you want to see moderated mediation? The easy way? Easy. I'm going to put that in air quotes, the easy way. None of this is easy, let's be clear. Easier. Relatively more easy. Or I should say less challenging, right? That's like a more positive, less positive sort of thing. It's less challenging. It's not easier. Okay, so the key idea here. She wanted to know whether the patterns of relationship that we just found differed between men and women college students in a binary way. So essentially what we're going to do simultaneously but separately is estimate a path model for the men in the sample and the women. This is not the same thing as a subsample analysis though, because the point of doing it separately but simultaneously is to test whether this slope is equal to the same one down here for the women, this one's equal, like basically the whole model, whether those things differ between the two groups. It does matter. To the extent that your sample sizes are more uneven, you have lower power to detect differences. So if you have a very small group, it's not going to go well, but doesn't stop you from trying. Now, Stata users are going to be quite happy at this point because SEM has anticipated this. And to test for whether each parameter in the model differs between these two groups is one line right here. And it's a special blue color that you don't see in Stata very much, as opposed to the navy blue that you normally do. Group, the variable in the data set that distinguishes my group, and then G invariant none means let everything be different. So separate but simultaneous, because then we can look at significance tests for each parameter to see if it differs between the two groups.
Because they're in the same model.
It's in the same model. It's in the same likelihood function.
Yes.
Yep. Yep. So you would lose the ability to make those explicit comparisons if you did separate. Yep. And that is a principle that holds more broadly. Like if you want to compare groups, don't do subsample analysis. Put in interaction terms that allow things to differ by group and see if they matter. Building the indirect effects, though, was a little bit of a pain. Yeah, so you'll note there's longer text in here because each indirect effect has to be for one group versus another. The 0 group, which is the baseline, or the 1 group. So, for instance, this one is mindfulness to the first mediator in the men. Yeah, I'm not going to be able to get through this, but all the combinations are here, basically. And the way that I figured this out is, I don't have it in this one. The coef legend is the command that gives you these labels. So it spits out your output and then the label of what that is called according to Stata. And I don't think you can change these as best as I know. So I made indirect effects and differences in indirect effects between genders for all possible ones. So, oh, here, look. Previous me knew that future me would not remember this and wrote it down for her. Comments save lives. So the X to M12Y pathway for men, for women, and then whether it differs. So this is what it was for men minus, note the continuer here, what it was for women. So I'm saying, is that combination of A times B different between men and women? That's one way I can ask for it. Did the same thing then for all the other indirect effects, total effects, etc. Oh, there it is. Yeah, coef legend. I knew I had it in here somewhere. So Stata makes it relatively easy to test differences in direct model parameters. Differences in indirect effects take a little bit more work unless you can find a way to get it to spit them out. They were not working for me last time I tried. In R, you're going to hate this. There may be a faster way that someone built in some function, but I didn't have it. So you got to write out everything. So for instance, dig into this here. Mindfulness intercept. I want to give the men one version of it, so that's the lowercase m, and the women another one. So this says, I would like this parameter to differ between the two groups, and here are the labels for what it's going to be within each group. Question?
Lisa, does the labels depend on what you have in your variable? What I mean is, if you have 0, 1, and 0 is male, we are using m because male is 0?
Yes. Yeah, the variable is coded men are 0, which is why they're first.
Okay.
So the labels would be backwards if I had it in the opposite order.
So if you backwards one of these pairs, you have bad data or bad model.
Then you wouldn't know whose results are whose, would be the issue. Yeah, so in that case, I might run one group separately just to double check that I am getting the same thing or close to it. So every parameter in here has 2 labels, one for the men, one for the women. That allows them to be different. Can you guess how I would set it up if I wanted to force them to be the same across groups? Instead?
Would they both have the same label?
Same label, exactly. That is called a constraint. So you're saying, hey, go find this slope and make it the same between these two groups. And to your question then, if they make it the same between the two groups and one group has like is 80% of the data and the other group is 20%, that combined slope is going to be weighted more heavily towards the 80%. All right, so other than the 2 labels for everything, the rest of the code is the same. Just a whole lot of it.
If you had 3, then it just has to have 3 labels in there?
Yep. Yep, so I told it what variable in my data set is organizing by group. So then it would be a variable that has like 3. I don't know what the upper limit is in terms of numbers of groups, but like in practice, anything past 4 is going to be a nightmare. Because if you think about it, like let's say that you have a test across 4 groups of one parameter and the test says, hey, it differs across groups. Well, there's 6 different ways that one thing can differ. Times how many parameters are in this model? 54. There is another way of answering the same kinds of questions called alignment, but that is an SEM level construct. If you wanted to test moderation that is involving continuous variables instead, they have to become boxes in your model for that. That's really the only way to do it. Okay, what am I looking at here? This is our output, it looks like. So any questions on the multiple group model?
What if you want more than one group? Is that an SEM question?
More than one group?
Yeah, so you group by sex, men and women. What if you want to do men and women, but then maybe you want to say, okay, over 40 and under 40?
Then you'd have to make a new 4-category variable and keep track of who's in what combination. And you could set up a pattern of constraints to test main effects by one dimension, main effects by another, and an interaction term. Mm-hmm.
Okay.
You can get nice and fancy with that. Yes, indeed.
But big.
But big. So model fit is still perfect because the model's still just identified because we let everything be different by group. So then it tells you, this is classic R, group 1 is the 0. Mm-hmm. Group 2 is the 1 because it's counting from 1 and I'm counting from 0. And I wrote this in here because I'm going to go insane otherwise. So yeah, you get all the results twice in terms of what the model said the parameters were for men, what it said they were for women. Then we get to the new parameters where I'm looking at indirect effects for each, total direct and indirect effects, and then differences in the direct effects, differences in the indirect effects. So I wrote out all that stuff.
Lines to make it easier for you while you're writing this?
Yes.
Okay.
Yeah, no, all this like formatting and stuff is stuff I do post.
Sometimes it does.
Yeah, no, I had to divide these to make it make sense. Otherwise, I was just staring at a column of letters that it wasn't getting in. Yep. M plus is closer to R in terms of the amount of labor that you would need to do. You have to label everything, and I did the lowercase and the uppercase with that. So note that I have model, which is blue, but then I also have a submodel, model women, which is the alternative model. And this, by the way, if you're a careful coder, you can use find and replace to do a lot of this work. So for instance, this was my original model where I didn't have M's or W's on the front of things, I just had what it was called. But I purposefully stuck a lowercase m in front of all of this because then I can copy this and find and replace case sensitively to a lowercase w. And as long as I don't have any other lowercase m's that would get moved around, then this takes your code and like does it in a second. So, and then here's model constraint with all the new things: indirect effects, total and indirect, direct differences in direct effects, differences in indirect, and all the things. So that was the story that got reported. Essentially, was which of these things differed by group and why. I don't know anything about the latter, but that was her job. And then this is an example of what it would look like if you just wanted to hold like one thing at a time. So for instance, this is allowing these relationships to differ, but then this one would not differ between groups because it doesn't have zeros and ones referring to it. So you can do sort of hybrid things where some things are the same, some things aren't. The same idea of that in R would be to just use one label, as we said. And it works the same way in n+2. If they share a label, then you're making that number be the same. And I think that's it. Yeah. That's it for example 6a at least. All right, are we feeling better? Is this more doable maybe? It's complex, but it's not difficult in the sense that you have all the pieces. You understand how to do the pieces. If you can run one regression, you can run 17. That's what this is. Do you want to see a logit?
Yes.
That's not required on your homework, so this is just sit back and look at the picture. Why not? Maybe we'll get to yours, Vladimir, maybe. We got like 15 minutes left.
He just lasts 1 minute.
So this is an example from a paper I wrote. I wrote this paper because I found one significant correlation. Yep, one. And this journal, Psychology and Aging, which is actually a very good journal, has a brief report format. So this is a paper that took up like 3 manuscript pages because it's about one correlation. I gotta tell you, the brief report format is a really good idea. If you have a little thing that you want to get out fast, like the manuscript itself was like 10 pages and it got reviewed really quickly and easily. So the story behind the story, these are based on data I collected as part of my dissertation. When I used to be a cognitive aging person and a methodologist, I was examining what predicts accident risk in driving in older adults. And I had a measure of a really crappy driving simulator that I had access to at the KU Med Center, in which I collected outcomes from a driving simulator task. And I'm examining to what extent characteristics like sex, age, visual impairment, measures of attention, and something I developed would predict that thing in the original study. I then got some bonus funding to call the people up 5 years later and ask, hey, did you actually like crash your car for real since you came and did my study? And I also asked them, did you have any accident, speeding tickets or anything like that? And I found the one significant correlation, I could find it on here, is that performance in the driving simulator significantly predicted who was going to have an accident 5 years later.
That's exciting.
It was a crappy simulator and I was really surprised. And so that's the name of the paper. Simulator driving performance predict accident reports 5 years later. Boom. You don't even need to read the abstract. That's it. So I spent probably longer making this diagram than I did writing the paper.
Wow.
I am very proud of it though,
That's
because I got all the things on it in a way that makes it readable by cheating a little bit. So like this black line heading into simulator right here, like this is the prediction for that and for that and for that. And the ones that are the dotted lines on the bottom ones, so the 0.29, the zeros, those are going over here. I also asked them to what extent they had limited their driving since they had been in the study. That didn't predict anything. And then I have all the original variables and this one. And accidents and speeding tickets happened 5 years later. And yes, reviewer 2 was like, how do you know that you should have your path arrows going from left to right? I'm like, because the future can't predict the past, dude. That's why. 5 years later. But thanks for reading carefully. And then I screwed up. Yeah, I know. I am fallible, as it turns out. Because 2010, Lisa, 2010, tried to put a residual covariance between accidents and speeding tickets, each of which is binary. And M+ yelled at 2010, Lisa. And I said, well, I guess I can't do that. And I still said that this model was just identified because I couldn't figure out how to put a residual covariance in. And 2017, Lisa figured that out, give or take, I would say. And this trick is to put this thing in here called a random intercept or a latent variable, because random effects and latent variables are the same thing. So these are slopes from an imaginary thing that are fixed to 1. And through the rules of path modeling, this then introduces a covariance between these two things, and that is the variance of this variable, represents their covariance. So it's a roundabout way to introduce a residual covariance when you're predicting logits. So that's why it's extra. Meaning that these blue lines right here do not have estimated parameters to them. They are forced to be 1. So when you have a latent variable that has 2 things that it's supposed to be predicting, it is under-identified unless you force the 2 slopes to be the same. And because what I wanted was the residual covariance to be represented by this circle's variance, I forced them to be 1 so I could estimate the variance. That's what makes this into a random intercept in exactly the same way that we talked about in longitudinal, and in exactly the same way we'll talk about in the fall. So, the model itself then has a few extra things because of the logits at the end. So in M+, the way that you tell it about you need a link function is the keyword categorical, and it figures out based on your data how many categories you have and what kind you need. So these are 2 binary outcomes. Link equals logit. We know what that means, right? Can you guess what the alternative would be? Probit. Yeah, it doesn't have log-log or C log-log. This particular model required a different kind of estimation called Monte Carlo integration. It's resampling. That's going to be a Jonathan question. I can't do estimation right now. It's just not. Yeah. So a few things. Do you remember the log of the odds of the probability of a 1, logits? These things right here that have dollar signs, these are called thresholds. Uh-huh. And I knew this was coming. That's why you saw this in like February. So an intercept is the log of the odds of the probability of a 1 in logits. A threshold is the log of the odds of the probability of a 0. M+ gives thresholds, whether you want them or not. And I always make the same joke because it's not really a joke. The symbol for a threshold in M+ is a dollar sign. Because if you understand this crap, someone's going to pay you. Actual money. Particularly in the world of psychometrics. People who start out at testing companies often have higher salaries than faculty, even senior faculty like myself. It's a growth industry if you can get in. So these are thresholds. Now, do you remember how I turned them back into intercepts? This was like homework 3. Reverse it. Additive inverse times -1. Yep, so I can get intercepts by making it that way. So then I have all my regressions in my picture, my residual variances for my continuous outcomes, my random intercept trick to allow my 2 logits to have an additional relationship, and then I did one example of an indirect effect using the labels that I added to the slopes over here. All right. Now, cough, cough, homework question. This is all I get for fit. That's it. I get a log likelihood from my model, a scaling correction factor for deviations from non-normality, AIC and BIC, and that's the end of the list. So model fit for binary outcomes using full information maximum likelihood is not evaluated in the usual way. The reason is because what normally would also be right here is something called the H1 model. That's the perfect model, where you have all possible means, variances, and covariances estimated directly. I don't have one of those in here. In categorical data, there is no direct analog to that. The analog is a giant contingency table of every possible pattern of response patterns for your binary or ordinal variables. So there is no model fit to the right answer that is readily and easily available. People have developed workarounds. That's an SEM topic. For now, just know that all the stuff about fit is going to go away, which is how I didn't know for sure whether my model was just identified or not, because I couldn't test the fit. But I now believe that that random intercept thing should probably be there.
Did you republish after you found it?
Nope. I did not.
Now, would it be a valid thing to do if you chose to?
I think it would. And so I actually have in the download file for this example, I have the original 2010 output and then the output from this example, so you can actually see how they differ. I highlighted the ones that differed meaningfully. Let's see, this one. So how they did in the simulator was related to the measure of attention I created in my dissertation, yay. The primary finding that how they did in the simulator predicted their likelihood of an accident is still significant. So the one thing that I was hanging my hat on is still true, even after I fit a better model. But these things sort of wiggle around a little bit, not just because of the addition of the random intercept, but also the change to robust estimation, which was not possible in 2010. That didn't come out till later, I think. Or at least I didn't know about it, let's put it that way. 2010, Lisa did not know as much. And then I tried to do it in Stata, but the results are different because of the way Stata handles missing data. It does something called equation-wise deletion, where it uses whatever things that could be used or that one model for it to fit it, but then otherwise it's incomplete. And M+ does something different. So it looks different and has different outputs and conclusions a little bit as of that, but I wanted to show you that example. And then for sample results section, see the original paper with this extra phrase in it. That, just shove that in the picture and into the text. Okay, Vladimir, it's 3:03. We can look at yours.
I have a question, Lisa.
Yeah. Do you want to talk about it or do you want me to?
Yeah, I can, but what can we do in case of hierarchical structure in our data?
Hierarchical structure?
Yes. Can we turn this into multi-level path analysis?
Multi-level path analysis, yes, we can. So you, essentially, like if you have a longitudinal study, you have variation over time as one level and variation across people as another. Each has a path model to it for anything that's measured repeatedly.
Like if you did this at 0, 5, and then 10 years later, you could see, how much better or worse that you were.
Yep.
Do you want me to talk about it? You can cover it too.
Well, I will just show the model, I think, because we're like running out of time here. But I wanted to at least show it because he made this glorious, lovely handout for you.
Yeah, thank you.
Here's the model.
Wow.
Was this Stata?
Yes, it was.
Yeah, so Stata has a nice diagrammer. And this outcome right here is nominal. What does it mean, Vladimir? Oh, I know. I've listened to your presentations enough. I should know this, right? It is whether or not you got admitted to university, not admitted, or you saw your test scores and didn't even apply.
Exactly. Yes.
3 different outcomes. So it has a little box in here labeling this multinomial logit, which I think is helpful. So technically speaking, this box is 2 boxes because it's 2 submodels. Remember the submodels? It's like a greatest hits collection. So we have first generation status, family income, and then test scores and rankings of your academic performance, and that all predicts your decision. Yep. And this is clustered data, right, Vladimir?
Yeah, it is.
Yep. So 2023, Vladimir did not know that, I think, but he does now.
I don't know how to do it yet, but I know what I should do.
We can do it. In that case, it's students nested in schools. And to the extent that students are not randomly assigned to their schools, then there's going to be school level things happening and people level things happening, and that should be 2 separate path models. Yeah, it gets ugly real quick. But I think he has, do you have code in here for them?
Yes,
At the end.
you will find the M+ code to do this.
Okay, excellent. So yeah, here's the script that he used to do all these things. The only thing that makes it different for nominal, there's like 2 parts. Nominal equals is the option to tell it that it's nominal. And then the submodels are represented with hashtags. So we have predicting the first submodel, predicting the second submodel. And the reference is the highest category for nominal. So you'd have to reorder your data if you want it to be a different one. And look, he wrote a whole bunch of words and stuff about how this works. So thank you for that. I never ever have time for it, but we're going to keep trying. So, all right, 3:07. Have we had enough examples for today? Never. I'll take that as a no.
The random effect, the latent effect.
Yeah.
Were the arrows, because they were pointing to the Y outcomes, right?
Yes, the arrows are going from the circle to the Y's.
Okay, so the random
There we are.
effect is also predicting the outcome.
Yeah, so this is, it's not really a predictor. It is a pile of covariance between these two that I had to trick into existing this way. Have you heard of bifactor models by chance? In IRT land? So bifactor models are factor analysis models in which you have like your traits predicting your stuff, but then your stuff has something extra in common that you want to control for or otherwise deal with. And so like a second factor could predict those to introduce a source of covariance for those indicators that need it. Like related to whether they're positively worded or something like that. That's an SEM thing too. All right. So yes, arrows from the circle to the boxes always, otherwise that's a completely different kind of model. And it's not identified in that case.
Do you have to, because like in the past, we couldn't get variances for predictors and for outcomes, so we had to trick the model into thinking it was a predictor by generating an empty model for it. We don't need to generate an empty model for this one.
Yeah, this doesn't exist. So we can't predict it with anything. At least not in this type of model. This is the covariance between these. Yeah, it's introducing a relationship between the two. Covariance isn't quite the right word, but it's close enough for our purposes.
So normally we check for covariances between predictors or predictors.
Yeah,
and
things we've
outcomes.
measured.
We don't normally look for covariance between outcomes.
Well, in multivariate models we do, because it's reasonable to think that someone who got in an accident might have been less likely to get a speeding ticket or more likely. Like there's some relationship there. I believe it's positive in this case.
So what would be the difference then between this, where we're adding a random intercept, and then in our homework, where I think we do have 4 outcomes, and you want us to look at the outcomes, the covariance between 2 and 2.
Yes, in your homework, these ending boxes are multivariate normal. So they have residual variances, which means I can directly have 2-headed arrow covariances between them. These are binary, which means they're in logits. They don't have a variance. So I can't directly give them a covariance. I have to do it in this roundabout sort of way. Okay, did I answer all the homework questions, by the way? Anyone stuck on anything I didn't say? No? Okay, I think I've hit them all. But if not, it's in the slides or it's in our brains and you can talk to us. Yes.
So when you are doing something new, like when you introduce this random intercept,
Mm-hmm.
is the only way that you know that you have set it up right is that you get results?
Yeah.
I mean, not just,
If it breaks, you may have set it up wrong, or there is no covariance between these things for it to do.
okay.
Yep.
What I'm most terrified about with statistics is that there is no homework website where I can enter my estimates
Yes.
and it turns green.
Yeah, you will not have green and red boxes in life.
That's so terrifying.
It can be terrifying, but paying attention to what your results are telling you and asking yourself, does this seem reasonable? Or like if you see a threshold in M+ of like 37,000, that's what it's estimated to be. Like, I don't think that sounds right. Like, just you can look for things like that. But yes, to your point, things still scare me. It's not like I'm sitting up here having learned everything. Like I'm still trying to figure stuff out on the daily. And as long as we're all going to be scientists and scholars who commit to continually learning, whether we're students or faculty or in the field, like that's what it's going to take.
Do you typically start with the simplest form of model that
Yes.
sort of does, and when you get that, and then you expand it a little bit,
Yes.
until you get to whatever it is that your goal is?
Yeah, I would not try to tackle these things all at the same time. Like in practice, I would build them up in layers or pieces, especially for anything that involves link functions, because that's going to be more likely to cause estimation problems. Yep. All right, 312. That means I need to stop talking about this so I can talk about y'all and say thank you. You got me a present. That's very sweet. I want to thank you all for your efforts this semester. I know you worked hard. This stuff isn't easy. You persevered. You showed up. Those of you who are here today, especially on the last day. I'm just really grateful, and I want to let you know that you have forever earned the right to bother me. Okay? I know. Like, if you're trying to run one of these models in the future and you have a question, and it's a specific question that I can answer, reasonably quickly, then shoot it to me. On one condition. Do you know what that condition is? Pay it forward. Because I had people, and I still have people, who answer my questions. And I answer your questions, and someday you will be in the position to answer other people's questions, and I truly hope that you do. Because that's how we all get better. And I'm glad to see so many of you from not quant specialties finding a reason and an opportunity to improve your research skills by learning more methodology. I honestly believe that's one of the best things you can do, whether it's qualitative or quantitative. Having a full toolbox of tools to do your research is going to make it better. So thank you all. Let us know if you need anything. Office hours next week, and have a great summer. Yeah, let's clap it out. So for the last time, bye Zoomers, bye Roomers.